All right, good morning, everybody. So we are going to look at some of the concepts in circular measure that is in your additional math syllabus, 0606 additional math. We'll start on this topic on circular measure. So as you can see, we have a circle drawn, and I have actually labeled some of the parts of a circle so that you actually understand some of these parts. So the most convenient part that you will know of a circle, I'm sure you know this is called the radius. All right, that's the radius of a circle. This whole thing that goes through the center of the circle, this is called the diameter. All right, if it doesn't go through the center, we call it a chord. All right, and some other parts include this shaded region inside. That is the actually a sector, and that's the area of the sector right there. And we have the arc length right here. So these are the various parts of a circle. Now, what we're gonna do, two things. We're gonna learn about radian mode. How does it compare to degree mode? And then after that, we're going to look at the area and arc length of a sector, basically this, all right? And more importantly, we'll look at it from the radian mode itself, all right? Okay, so let's see. Now, the main idea that you have to remember today is that pi radian actually equals to 180 degrees. So that is the direct conversion. So pi radian, right, equals 180 degrees. So when we say pi in radian mode, you just convert it into 180 degrees in your mind. Okay, so let's look at first two conversion. We want to convert between radian to degree and degree to radian. Right, so let's dive in. We're going to look at radian to degree first. So since we know that pi radian is equal to 180 degrees, then if I divide both sides by pi, then 1 radian will appear here, and that will be equal to 180 degree divided by pi, in terms of the conversion. So what happens if I have pi over 3 radian? I want to know what is the corresponding angle in degree. So I just want to multiply pi over 3 with 180 degree divided by pi. So I'm going to do it right here. Pi over 3 times 180 degrees divided by pi. And notice that pi and pi can cancel out because they're common factor, and 180 divided by 3 would give you 60 degrees. All right, so that's how you get from radian to degree. You want to multiply by the factor of pi divided by 180 divided by pi. All right, now similarly we'll do the same thing. If I want to convert pi over 2 radian into degree, so all I want to do is I want to multiply pi over 2 with the factor of 180 degree divided by pi. Similarly, I will cancel out the pi, and I'll just have 180 divided by 2, and that will lead me to 90 degrees. Okay, so again, the factor that I want to multiply through is 180 degrees divided by pi. Now, very similar to radian to degree, if we want to convert degree to radian, we will do kind of the same thing, but our factor is no longer 180 divided by pi, but instead it is pi divided by 180. Okay, so similar, if you have 180 degrees is equal to pi radian, so if I divide both sides by 180, so 1 degree is pi over 180 radians. All right, so if it's 30 degrees then, so what will be my corresponding angle in radian? So I'm going to multiply 30 with pi divided by 180. All right, this is 1 and this is 6. So it will be pi over 6 radian. Okay, so that's how you convert it out. And again, this factor is pi divided by 180. Okay, if we tried 60 degrees, very similar. So 60 degrees times pi by 180. We are going to cancel out the common factor. This is 1, this is 3. So the answer will be pi over 3 radian. All right, so that is basically how you convert between radian to degree and degree to radian. Okay, now the last part to this is we're going to look at the area of sector, all right, and arc length. So a sector is just kind of like a piece of a circle, a slice of it in a sense. And the sector is governed by the angle itself. This is the angle of the sector. We call it theta. Now you have learned that in extended math as well, and we know that the area of sector in extended math is area of sector is theta divided by 360 times pi r square. So it's like a portion of a circle times the area of circle. Now, if we want to convert that into radian mode, all we want to do is this. We want to convert all the degree in this formula into radian. So since we know that 180 is equals to pi radian, so 360 degrees would be 2 pi radian, right? And we're going to multiply by pi r square. And notice that pi and pi can cancel out because they are common factor. So all in all, when we simplify this, this will be half r squared times theta. Okay, so this formula we will use this for radian mode. So as long as in radian, you know the radius of the circle and you know the angle of the sector in radians, yeah, this theta is in radian, then you can find the area of sector. All right, maybe let me highlight this here. Okay, now for arc length, very similar. In the extended math syllabus, you know that the arc length is theta by 360 times 2 pi r. So all we want to do is this. If we want to find the arc length in radian mode, we want to just substitute 360 degrees out with 2 pi. And notice that the 2 pi will cancel out very nicely. And all we have left is r theta. Alright, so that will be the arc length if you're using radian mode. Again, this will be the formula that you want to use. As long as you have the radius of the circle, or the sector in this case, and the angle of the sector in radians, then this formula will be applied to get the arc length. Alright, so all in all, this is just a quick video summary of the main concepts in circular measure. If there's any part that you're not sure, you can always pause the video and watch it again. And yeah, so basically that will be it. Alright, I'll see you in the next one. Cheers.